Yes, good morning, all of you. The screen is visible to all. One of you can confirm whether the audio and video is clear. Okay, we'll start the class. So today, coming to the next part of the syllabus, that is, we left with Mach number and propagation of the disturbance in the given fluids. Okay, so today is the maybe last class of this fluid mechanics. I hope we'll take the Mach number, the importance of the Mach number, and different types of the uh, flows depending upon the Mach number that we'll discuss today, and we'll take some numericals to understand the importance of the equations. Okay, so coming to the next part, that is Mach number. So this also we have seen the non-dimensional number in the dimensional analysis chapter. Okay, so here Mach number is very important as an aeronautical engineer rather than mechanical engineer. As an aeronautical engineer, this Mach number is there for any type of vehicles or any type of bodies which are flowing with depending with the speed of sound. Okay, so whenever you are comparing the speed of sound with the speed of body which is moving in any given fluid or submerged liquids, so in that conditions we are going to use this Mach number as a reference uh, number which defines at what speed with respect to speed of sound the body is moving. Okay, so coming to the definition of this Mach number, so it is a square root of ratio of inertia force to the elastic force. Okay, so by taking these two forces, so as we discussed till now, how the inertia force depending upon the velocity of the disturbance and elastic force in the fluids. Okay, because the disturbance in the fluid, it may be a disturbance due to sound, it may be disturbance due to pressure difference in the air, or the disturbance because of the any blast or explosions. Okay, in such things, the moment of this disturbance in the given fluid, that fluid molecules are elastic in nature. So how fast this elastic property of the fluid will help us so that disturbance can move at a given speed. Okay, so by taking this ratio, that is inertia force to the elastic force under square root, that defines the Mach number. So this is the definition. Now, after simplifying this definition, I can write the inertia force as rho AV square divided by elastic force, that is K into A. That K is bulk modulus of elasticity for the given fluid. Okay, so for a given area of the flow, the bulk modulus, how much of the fluid is there, that you can multiply with area. And in the numerator, for the inertial force, the due to the inertia of the fluid density itself, how it is moving. So it is moving means it is having some velocity. So taking these ratios, I can get after simplification, it will be square root of, after cancelling a on numerator and denominator both side, I can also write square root of v square by k by rho. Or I can also write it as taking out the square root and square of v, I can write v by square root of k by rho. So finally, what I can tell is Mach number is also the ratio of velocity of the body, what is flowing or what is moving. C is the velocity of the speed at which it is moving, because we also saw that in the last class, square root of k by rho, the bulk modulus of the given fluid to the density of the fluid. If it is under square root, it defines the speed of the sound in that fluid. Okay, so just if you recall the earlier equations what you have derived with a bulk modulus, that is here, C equal to square root of k by rho. Okay, so this I am replacing with C here. So that becomes V by C. The meaning is this is a non-dimensional number. Okay, because speed of sound and speed of body both are in meter per second, you can consider. So the units will be cancelled. So it is a non-dimensional, it is a non-dimensional number. And once the units are not considered, we are talking about only number. It may be 0, 1, 2, like that. So depending upon that number, I can tell at what speed the body is moving with relative to the speed of the sound. Okay, or also you can define velocity at a point in a fluid. The point in a fluid, in the sense, the point itself is a body, maybe aeroplane or a submarine which is flowing in the liquid sea water, or it may be a jet plane, any type, or it may be vehicle also. Vehicle, if it is moving more than Mach number, also you can consider that at what Mach number the vehicle is also moving on the ground. Okay, so that velocity at a, or velocity of the body in the given fluid, to the velocity of the sound at that same point, okay, at a same time, if you consider, then I can call it as Mach number. Or you can define by this also. This is the uh, first definition, that is square root of ratio of inertial force to the elastic forces of the fluid. So now coming to the different types of flows depending upon the Mach number. Just a minute. Yes, am I audible? Okay. So later we'll see one video also on this Mach number, how it can be defined, because directly if you go by theory and analyze the Mach number and distribution of disturbance or the sound disturbance in the atmosphere, it's very difficult to understand only by theory. So we'll see one video also in between. So coming to the classification of different types of flow based on Mach number, you already know some of the types of flow. So those types of flow are so generally they classify by these three types of flows. One is subsonic flow, then sonic flow, then the supersonic flow. So you might have heard also in the TV channels or some observing some videos on the aircrafts or some jet planes. So you might have come across this type of flows. So similarly here, how these flows are classified are, if a body is moving in a fluid which is equal to the speed of sound at that time or at that given fluid, then it is called as sonic flow. Okay, where Mach number equal to 1. So when Mach number is equal to 1, when velocity of the body, just a minute. Sorry. When velocity of the body is equal to velocity of the sound, means it is Mach number is 1. Just a minute. Mouse is not operating properly. Yes. Now coming to the different Mach numbers, if the Mach number is less than 1, in the sense, if the velocity of the given body, say for example a helicopter, if that helicopter cannot move with the same speed of sound, then Mach number will be less than 1. Say for example, a vehicle which is moving at 60 km per hour or 100 km per hour on the land. Okay, that is not taking the speed up to the velocity of the sound. So what happens? Directly it will be Mach number less than 1. So in such conditions, we are claiming that flow as a subsonic flow. Okay, it is less than sonic speed. Next is, if the velocity of the body, or say for example a jet plane is moving, or some a bullet is fired in the air, or it may be a missile which is flowing at a very high velocity compared to the speed of sound itself. Okay, where the these speeds are required here is because one thing you can remember, say for example, I want to, uh, if in defense, if you see in the defense, if I want to target something and I want to explode the some points, okay, opposing uh, in war or something, you can say, not to take other words, okay, if in war, if you consider some target points and you want to explode them, so in that condition what will happen is the missiles or the explosive materials what we were using, that should be moving more than the speed of sound, in the sense the opposing person should not hear the sound until it is exploded. After explosion only he should come to know what it is targeted and what it is hitting. So in such conditions, majority of the cases, and also to move at a very faster rate, which is more than the sound of speed itself, means the observer or the person who is standing there, even he cannot listen the sound also. He can just observe or he can see, but until that the time will be after the explosion only he can see listen the sound. Means the supersonic flow means the velocity of the body itself is more than the speed of sound itself. So in such conditions, what will happen? We are going to call it as supersonic, hypersonic, or hypervelocity conditions. Or one more classification I have taken here. This chart you can see, or it is also classified by two different flows. One is internal flow, one is external flow. If you go by internal flow like pipes and uh, ducts we have studied in the syllabus, okay, in the pipe or the ducts if it is flowing, depending upon this Mach number. So as I told just now, we are same thing we are going to classify as subsonic, sonic and supersonic flows. But if it is an external flow, for example the plane or the submarine, okay, or the vehicle on the land itself, whatever it is, if it is moving and air is flowing outside the body, okay, so in such conditions, as you can take the example of your aeronautical field itself, where maximum bodies are flowing inside the fluid and fluid is moving outside the body like a plane aircraft. So in such conditions we are classifying the flow in these types, or apart from this you can see here, okay, if the flow of the fluid is external, then the Mach number, you can see the Mach number, if the Mach number is below zero point 0.3, okay, if the Mach number is below zero point 0.3 or velocity of the body is very less, in that condition the liquid or the fluid like air behaves like an incompressible fluid. Okay, at what speed? Say for example we have taken the experiment like this. What is that experiment? This cylinder with a piston, this we had taken. So at what velocity the piston moves, if the same velocity the air is also moving or the disturbance is also flowing, then it is acting like a incompressible fluid. And if at very high speed, if I move the piston, suddenly the pressure wave cannot be generated. It may take some time or it may be generated very fast, depends on the different speeds. So in such condition, it is behaving like a compressible fluid, where it is having some change in volume, then it is giving the shock waves or the sound waves. So below Mach number 0.33, if you see, then we say that the air or the gas or any compressible fluid, it is acting like a compressible or incompressible fluid, then it is called as incompressible flow if the Mach number is below 0.3. Okay. Next is, as we have seen, so very accurate value if you want only in the external flow. Okay, so don't get confused then with different numbers and different types of flow in different books. So generally we consider for the external flow, if the Mach number is 0.3 to 0.8, not 1, up to 0.8, it is called a subsonic flow. And between 0.8 and 1.2, it is considered as transonic. Means we cannot say subsonic or supersonic or even sonic also. So in such condition, it is transonic flow. Next is 1.2 to 5. If the Mach number is up to here, or some books they have given 3 also. So up to 5, you can consider supersonic flow. Then later, if the Mach number is 5 to 11, okay, very high Mach numbers, more than the speed of sound, 5 times or 11 times the speed of sound, if you consider that condition, we are calling it as hypersonic flows. So many times you might have heard hypersonic jet or hypersonic missile, something like that names will be given. So it means it is moving at this speed, 5 to 11. In between that speed, that it is moving well before the sound speed. Okay, because you might have seen the planes moving in night also. Only you can see the light. You cannot see the, or you cannot listen the sound also. Or even sometimes the train may be moving, say for example, around 500 or 1 kilometer away. Just you can see the moving of the train, but you cannot hear the sound. Okay, like that, the speed of the train or whatever the disturbance is there, it is not reaching the listener or the person who is standing away from that. Okay, even for the plane also, if it is moving at these speeds, you cannot listen the sound in given areas. And later, if the Mach number is above 11, if the velocity of the body is more than 11 times the speed of sound, then it is a hypervelocity flow. Okay, these are the just classifications I have given to just elaborate, because later you may be studying in other subjects also. This is not the scope of fluid mechanics. Our fluid mechanics scope is subsonic, sonic, and supersonic flows. Okay. So next we'll see how to observe these disturbances, or before that you can take some problems. Okay, so that we can understand what is the importance of these equations, why we need to solve the problems. So before going to the disturbance characteristics and sketches of the disturbance, we'll solve some problems and we'll take the Mach number and its distribution. Okay, you can note down the few examples. Here we need to find the sonic velocity for the following fluids. So whenever in the problem they may tell sonic velocity, or they may tell speed of sound, or they may tell disturbance in the fluid. Okay, so all these uh, points are same. So here they are telling find the sonic velocity, means we have to find the c. So c value we need to find. By which equation we don't know. So by which equation we have to use, that will be given in the problem. First problem is crude oil of specific gravity 0.8 and bulk modulus 1.5 giganewton per meter square. So this is given. Next given is mercury having a bulk modulus of 27 giganewton per meter square. Now you can see here both the things they have given the bulk modulus. So any equation, if it is relating the bulk modulus with the sonic velocity, or if it is relating with specific gravity and sonic velocity, we have to recall that equation. Okay, so that equation means I know that c can be given as square root of k by rho. Now rho means we can relate this specific gravity with the density. I hope you are understanding. So specific gravity is given 0.8. From this one can find out the density of the oil or this density of the mercury, which is required for this formula. And bulk modulus directly they have given in giga Newton per meter square, and here also for the oil 1.5 giga Newton per meter square. So you can see how much is the bulk modulus, which is higher than the other, and depending upon that how the speed of the sound will change, that we'll see in the problem. So in the oil, the speed of the sound is, or sonic velocity of the disturbance is, or the speed of pressure difference in the air is, or the oil is given by square root of here bulk modulus of oil 1.5 giga 10 raised to 9. So Newton per meter square, it is in SI. So 1.5 10 raised to 9 divided by 800. See, properties are from again the back to the first chapter only. Only the formula is new formula. Okay, so 1.5 into 10 raised to 9 by 800, that is coming on around 1369.3 meter per second. Means the speed of disturbance or the sonic velocity of the disturbance or the sound is 1369.3 meter per second in the oil. Next, coming to the mercury, if you see the speed of sound here, which is very high compared to the atmospheric air. Speed of sound is here high because molecules are very near and fluid is very high density with high bulk modulus compared to water and air. Mercury, if you see, is very high dense fluid. K is given. You can substitute 27 into 10 raised to 9. Then density is given. So density of the mercury can be found out by using either specific gravity, which is not given in the problem, but you have to remember this density directly, 13,600. Because till now you have done all the labs with this density of mercury. You can substitute here and you can find the answer. So speed of that or sonic velocity in this mercury is around 1409 meter per second. So have you understood this problem? So what we have found in that problem is we have found the disturbance at what speed it can move in the given oil and mercury by knowing bulk modulus and the density of the oil. If you take the solid, the bulk modulus and the density may be very high, the speed of disturbance may be very high, like that. The next part we can take. Yes, here you can see an aeroplane is flying at a height of 14 kilometers. Okay, so say for example, I am the observer. From this point, it is at 14-kilometer height. The aeroplane is flying, where temperature is minus 45 degrees centigrade. So temperature is minus 45 degrees centigrade. Height is given 14 kilometers. The speed of the plane is corresponding to Mach 2. Means it is in supersonic flow because Mach number is more than 1. It is in supersonic flow because what they have given? Directly they have given the Mach number. They are not given in speed like kilometer per hour or meter per second velocity. They are not given. They have directly given the Mach. So Mach 2, it is the speed of plane. Find the speed of the plane if R is 287 joules per kg Kelvin. What is R? So can anyone reply in the group or the meeting? What is the meaning of that R? Yes, any replies? Yes, very good. It is a real gas constant. So for the given air here, as we assume that it is moving in air, okay, so R is 287 joules per kg Kelvin. In any problem given in such types, if they have given kg or kilojoules per kg Kelvin, then you have to convert this into joules per kg Kelvin, then you have to substitute as a SI unit. Okay, please remember this. So R is directly given in joules per kg Kelvin, so I'll substitute 287 directly. And gamma is 1.4. So by knowing these numbers itself, I can tell the plane is moving in air only. Okay, so now by seeing these values, now we need to find out the speed of the plane. Okay, so we need to find out the speed of the plane. Mach number is also given, and also we have to find out for the Mach number we need the speed of sonic velocity or the speed of sound also, because Mach number itself is what? V by C. So like this, you just analyze the problem. Now, once after analyzing the relations which relates, okay, which relates the speed of the sound to R and gamma, which is that equation. I will go back to the theory and I will recall that equation, which relates speed of the sound C here. So if anything is not mentioned, now see, nothing is mentioned in the problem, but gamma is given, R is given, means it is a adiabatic process. So by using this adiabatic process equation, what I can do, I can relate the speed of the sound C with gamma, R, and temperature is also given in the problem. So we can solve for C equal to square root of gamma RT. Very simple. Well, note down this temperature. So as we are using the state of equations or the gas equations, so converting this temperature to Kelvin is very important. So minus 45 is given, plus 273, it will be 228 Kelvin. So temperature at which the plane is moving is 228 Kelvin. Mach number is 2. Real gas constant is already given in joules per kg Kelvin. No need to convert. Gamma is the constant. Now coming to this equation, I'll substitute the equation to find speed of the sound or sonic velocity of the disturbance. So that is square root of 1.4 into 287 R value. Temperature value is, after converting to Kelvin, it is 228. Okay. So finally we got the speed of the sound in air. So speed of sound in air, always it is near between 340 or 320 only. So it is 302.67 meter per second because it is depending on temperature, okay, and also the different characteristics of the air. So now we got the sonic velocity is around 302.67 meter per second. Okay, so next from this is not the speed of plane now. This is the speed of sound. So now Mach number is given, C is found out. So what equation relates to these two values? That is Mach number. Mach number is V by C. So by this equation, one can find out now V value by substituting Mach number 2, which is given in the problem, and C value we have found out 302.67. So now I can tell the velocity of the body or the speed of the body is 605.34 meter per second, maybe in vector quantity. And other thing I can find out in kilometer per hour if you want. See, in the solution you can keep meter per second as it is, or you can write in kilometer per hour also. So if I write in speed kilometer per hour itself, I can convert this 605.34 into 3600 for converting second to hours. Then meters to kilometer I will divide by 1000. So finally the plane is moving at the speed of 2179.2 kilometer per hour in the air. Any doubts in this problem? So one can just substitute in the calculator and just confirm the answers whether they are correct or any mistakes they have done. Okay. Next we'll see. Okay, next thing here is, this is a very important part in this chapter, that is compressible flow. Propagation of disturbance in the compressible fluid. So compressible fluid, you can directly assume the air itself. Okay. So when the disturbance is created in compressible fluids, how it is going to propagate at different Mach numbers, that we are going to discuss here. So as already I have told you, it all depends on the Mach number. It also depends on the elastic property of the given fluid. Okay, different factors will be there. Now here we are going to consider one of the projectile. Projectile means anything which is thrown in the air. Okay, any small rock which is thrown in the air, it is going to travel by a projectile movement. Or a bullet fired in the air, after some distance, it will lose its velocity and it will fall down to the ground. That is going to form one projectile in the atmosphere. Or a missile which is flowing at a very high speed and it is thrown by some device. Okay, so like that, these objects which are freely thrown in the atmosphere, we are going to call them as a projectile which is moving in a straight line. We are going to assume here, we are going to assume it is moving in a straight line because A to B, whatever the distance traveled is there here in the sketch, A to B, we are assuming here it is moving in a straight line for a given small time. But if you consider complete projectile profile, it will be moving with a given different directions. Maybe in the initial stage, it may be a straight line, then it will fall down to the ground. Okay, so like that, the projectile distance and travel profile may be changing for a given time. But here we are going to assume it is moving in a straight line with a velocity v because the body is moving, bullet is moving. So that velocity is v, not the speed of the sound. Speed of the sound or the disturbance of that bullet fired, that disturbance we are taking it as c, constant speed of sound or the sonic velocity c. Okay, so Now we can consider at time 0, say for example at time 0, that projectile is moving from A to B at given different times. So similarly at time 0, we can consider it as A because we have started from A, so time is 0. Once it reaches B, the time will be higher. So the distance traveled by AB, you can write it as, we want to find out the distance in meters. I will take velocity into time. So meter per second into second, if we consider, the distance will be in meters. So I can multiply V into T. Similarly, to find out the disturbance, how it is going to propagate from that point A or from point B or in between some 4 points what we have considered here, how the disturbance is going to generate and distribute. For that, I can draw the circles by taking the radius c into delta t. So c here is speed of sound or the speed of disturbance. So that's why I'm taking velocity as c here. And delta t is what? The change in time, or for what time we are finding the speed of the disturbance. So that circles, what it indicates is the speed at which the sound is traveling or speed at which the disturbance is traveling for a given point. And from A to B, how the speed of body is changing. A to B, that is V into delta T. The circle radius or the circle profile or the sphere, if you see, that is C into delta T, where the disturbance is traveling in the atmosphere. So this disturbance is always in 3 dimension. So this it is going to generate some spheres. But to study in this uh, screen or something, we have taken the 2 dimension diagrams. So before going for different types of these profiles, you can just assume a stone is thrown in the water. A still water is there. Say, for example, in a lake, water is not moving. In a tank or a lake, you are going to throw one stone. That stone speed is velocity of the body v, that is thrown in the water. So that point is shown here. Once it is thrown, what will happen? Say, for example, it is going to assume at the surface of water or below the surface of water a zero velocity. It is going to reduce the velocity once it is thrown. Then once it is thrown, what will happen? The disturbances will be created in the water layers. This you might have seen anytime. Okay. So what will happen? The disturbance from the center, it is start flowing like a small waves. Okay. From this center point, the disturbance of the water molecules in the water molecules, the disturbance are going to propagate from center to the other distances. So these rings, what they are forming, it is nothing but the disturbance formed in the water. Okay. See here, at time interval given 1t, if you see, it is going to travel by this c into delta t. Second interval of time, if you see, it is going to travel by 2c delta t, like that. I hope this is understandable, this sketch. So similarly, after 3 seconds or 3 minutes, if you see, the profile of the disturbance is reached after far distance, that is 3 into c into delta t, after 3 times of the given velocity of stone. So whatever the center points we have considered is for the given body. And whatever the circles I have drawn here, like a stone thrown in the liquid water, these disturbance will show us the disturbance created in the liquid. I hope the point is clear. In such situation, even in air also, if the velocity of the uh, body it is very less or zero also, in such cases it liquid behaves like an incompressible fluid, like water which is there in the tank, and stone, if you just put it inside with a very low velocities, it is going to create some disturbances like this. The point is clear. So similarly, like this, we are going to consider with a different speed. If the Mach number is less than 1, like zero point 0.5, or if the Mach number is equal to 1, or if the Mach number is 2, how these profiles are going to be generated. To just consider the disturbance is going to travel in which direction and how it is going to transmit, and which is the silence zone and which is the disturbance zone that we are going to consider. So inside this circle, if you see, these are the disturbance circles. One can observe the disturbance inside this circle. At this time, if the observer, say for example, I am standing here outside these circles, I cannot observe the disturbances in the water. Okay, so like that we are going to consider at a given time and at a given speeds, the disturbance zone and the silence zone where it is going to be created. So before this, I'll take one video here. Yes, do we need any break here or we'll continue the class? Okay, after break means you just inform other students because attendance is up to 30. Please inform the remaining 30 students to join the class so that they can see the video of this propagation of disturbance. And later we can take some say simple examples so that all 60 students can understand this important topic. Okay. So I think we'll meet at 11, I think. Okay, I'll stop the class here. I'll just keep the mic. At 11, we'll come back to the class and just inform all other students to join the class. Yes, we'll continue the class. Okay, all of you can see the screen. Yeah, I'm going to play one video now. So in that you can observe how the velocity of the body, if it is less than speed of sound or the speed of sound when it is moving, the disturbance are created, and when it is heard or when it is listened by the observer, or if the speed of sound and if the body speed is both are same, and how we can listen the sound. And whenever the Mach number is more than 1 or the body is moving more than the speed of sound, then how the speed of the disturbance is going to be generated. So that I'm going to try with this video to explain you all. So just observe this video, later we can explain the theory part. Okay.
Writing is not that easy, but Grammarly can help. This sentence is grammatically correct, but it's wordy and hard to read. It underlines the writing message and the word choice is bland.
So please observe this video.
Many aircraft, mostly military, are supersonic. They can fly faster than sound. When they do, they produce a sonic boom. We hear this boom before we hear the noise of the airplane. What makes this sonic boom? And why do we hear the sound of the airplane only afterwards? Sound expands in a sphere. The sound source produces vibrations which travel in all directions as waves of compressed air.
This is the orange color point. What you can see is the body. Okay, the disturbances created by that body are traveling in all 3 dimensions as a sphere. So inside this sphere, the disturbance is created. Outside the sphere, disturbance is not still created. But after some time, it is going to occupy that area also.
So the sound waves move in 3 dimensions. We can make it clearer if we show them in 2. A white circle will represent a single wave of compressed air. Now here is the sound source. And here is the person who hears the sound. First, the situation where the sound source doesn't move. The compressed waves of air travel in regular succession, equally spaced.
See, as I told, the observer at this point, when he is hearing the sound, that you can see the sound here. After creating the disturbance at this point, okay, if the velocity of the body is 0, velocity of the body is 0 now, it is not moving. And after that, with the speed of sound, he is going to hear the disturbance.
distance between two compressions is called a wavelength, represented by this symbol, the Greek letter lambda. This has shown how the compressions expand when the sound source stays in place. But what happens when the sound source is moving?
Now see the body movement.
We'll represent the speed of sound by the letter C. V stands for the speed of the sound source. Let's see what happens when the speed of the sound source is half the speed of sound.
See, half the speed of sound means it is Mach number less than 1, subsonic flow. In that condition, how these profiles are going to be generated?
V equals 1/2 C. When the sound source moves, the waves of compressed air in front of the sound source are closer together. This means that the wavelength here is shorter than the wavelength of the stationary sound source. And behind, the wavelength is longer.
Now see the sound waves, how he is hearing one after the other continuously. When the body is coming near to the observer, when the Mach number is less than 1, not 0. Okay, body is moving continuously. So when say for example, in this case, you can assume a helicopter is moving. When it comes near to the observer, he can hear the sound. Once it leaves the observer, the sounds will be heard after some times. That's why he's showing that wavelengths larger after the body crosses the observer, how the wavelengths are more. And before the body comes to the observer, the wavelengths are very short. He can hear the sound continuously. When the object is coming near to the observer, once the body leaves the observer, the sound will be heard later. The speed of the sound will be less. It's like a helicopter.
Now let's look at the picture when the sound source moves at the same speed as sound.
So now he has taken example of Mach number 1. When the speed of sound is equal to the speed of body. Okay, the plane is just take off now. Assume that the plane is moving exactly equal to sound of speed in the same fluid.
When V equals C.
So now what is happening? Both velocity of the body, that orange color body, the speed of the sound where the wave or the disturbance is generated, both are at the same point because the body cannot move more than the speed of sound. That's why it is V equal to C or Mach number equal to 1. And when the body is moving, the waves or the speed what is generated or the disturbance is generated, it cannot travel more than the speed. So both are on the same point. You can see there, both on the same point. Until the body or the disturbance both reaches the observer, he cannot listen the sound. Once the body reaches the observer, then only he can listen that disturbance or the speed of the disturbance. Later, he is going to observe these sounds. Whatever the waves are generated, the points are generated behind the object. These sounds will be observed after some distance.
The compressed waves accumulate. They will all reach the observer at the same time. He hears a loud boom. This time, the sound source will move faster than sound at supersonic speed.
So this is now Mach number more than 1, like supersonic or hypersonic or hypervelocity, whatever the condition. So it is Mach number more than 1. So in this condition, you only can tell me the body is having speed more than the speed itself. So body will be moving faster than the speed of the disturbance. And here what happens, even though the body reaches the observer, he cannot listen the sound. That you have to observe in this situation. Or you can real time you can recall any jet plane is moving, not the aircraft. Aircraft may be moving exactly Mach equal to 1 or 2, very near to that, or transonic flows. But if you recall any jet plane, if it is moving at very high speeds in the atmosphere or very near to the land itself, in such conditions, these phenomena will happen.
For our example, we will have it move twice as fast. Let's say that the observer is on the ground below an aircraft. The wave compressions now form a cone.
See, the body is far away from the disturbances created. Disturbances are created after that because body is moving more than the speed of sound.
This time, the sound source will move faster than sound at supersonic speed. For our example, we will have it move twice as fast. Let's say that the observer is on the ground below an aircraft. The wave compressions now form a cone.
See, when he listens the sound, after body traveling the observer. See, body after traveling, after some time, he is
This
going to
is
listen.
easier to see when we begin to draw in more of the innumerable sound waves that are actually generated.
So this
The
is
more
going to
waves,
form one cone.
the more obvious the cone. On the surface of the cone, the compressions are very close to each other. They combine to form a percussion wave, which a person perceives as a very sharp booming sound. An airplane flying at supersonic speed produces a conic percussion wave, which follows behind it. Wherever the percussion wave hits the ground, the supersonic boom can be heard. Now, at the house on the river. Now, at the house near the woods. The percussion wave produces more than just a loud, startling sound. It can break windows. So to avoid damage and annoyance, aircraft aren't allowed to fly low at supersonic speeds over settled areas.
Okay, I hope the video is clear to everyone. How the disturbance is going to follow depending upon the speed of the sound. Okay, now we'll see the theory part to understand with some relations. So in this theory part, what they have done is they have tried to draw these circles depending upon the same theory, what you have seen now. So now in the first case, when the Mach number is less, as I told, if the Mach number is less and the body is moving, see the direction. The body is moving from A to B towards B, okay? And the speed of the body is less than speed of the sound. So in such cases, what will happen? The speed of the disturbance or the sound is traveling more faster. So circle you can see from A, the circle drawn is this outside circle, that is C into delta T. C delta T equal to V delta T at first position. You can consider point number 1. So 1 into V into delta T is the velocity or the distance traveled from A to B. You can consider 1 at one point A. Same thing if I consider for the C delta T, 1 into C delta T, the circle drawn is here, outside circle, complete outside circle, taking A as a center. Now similar fashion, in between A to B, all the points they have considered and they have divided the same circle into different parts. 3 by 4, 1 by 2 and 1 by 4, they have drawn the circles. Now here what we need to understand is zone of the silence. This is the zone of silence actually. Zone of action is inside the circles where the disturbance is heard. So the body speed is less than the speed of disturbance. So disturbance will be heard first. Then body will approach the observer. Say for example, train. Train is moving. Before it is starting from the station itself, we can hear the sound of that horn. And once it reaches the uh, any gates, what will happen? Later we are going to listen its sound, but the disturbance is heard earlier only when the Mach number is less than 1. Now next case you can see in this sketch Mach number is equal to 1. This should be equal to 1 and V should be equal to C here at the below. So make the corrections. Here what happens is velocity of the body and velocity of the speed both are same equal, means it is moving at Mach number 1, means it is moving at a same speed of sound in that fluid in the air. So say for example it is moving from A to B, say for example on simple plane or helicopter moving at Mach number 1. In such cases what you can consider here is at one point 1 into C delta t, the circle you can consider and you can draw the circle. Similarly, until if you reach the point B, until this point if you divide the points into 3 by 4, 1 by 2 and 1 by 4, okay, and if you try to draw the circles, both are having the same magnitudes or all the circles are meeting at a same point. This indicates at Mach number equal to 1 or velocity of the body is equal to C or the speed of sound. When the body is moving from A to B for a given distances, the disturbance will be created up to the same point. See here, the body or what you can tell is as the body moves near to the observer, same point, the disturbances are also created. And the zone of disturbance is on the left hand side, these circles. On the right hand side, after this circle, same point, you can see the zone of silence, where the observer cannot hear the sound until it crosses the observer. Same fashion, you have seen the cone, formation of the cone. So here you can see the body is moving more than the speed. See the magnitude A to this point, then this point and B up to B. The magnitude is high. Only the speed of the body or the velocity distances are high, but the circles you can see, circles are very small. Means the disturbance is still not reaching point B. So to find that disturbances when it will be reaching, so what they have done is they have created one cone here by joining the tangent to the circles. All the circle tangent line if you join on both sides, you will find one point B. So this point B, from the point B, you can see the three-dimensional cone is formed. And inside this cone, whatever the bodies are coming or the objects are coming, that can hear the disturbance. Okay, that can feel the disturbance inside this cone only. And the before the body reaches the points or the next point, the disturbance is reaching. Okay, and depend upon this magnitude of velocity, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this angle, whatever is the angle made by this half of the cone, is called as Mach cone angle. Okay, Mach cone angle is alpha. It is denoted by alpha here, and this is the Mach cone. And you can see this inside this cone, whatever the area is there, it is the zone of action where the disturbance one can observe. And outside this cone, zone of silence is shown. So this thing you have seen in the video, where the body is moving at very high speed. Until body crosses the object, you cannot hear the sound or you cannot hear the disturbances. So that all points we are calling it as zone of silence. And once the disturbance is heard, that point becomes a zone of action. I hope the point is clear. Now by taking this cone, the alpha angle can be found out. Now here we know from the cone angle alpha, if you consider here at the B half angle, if you consider alpha, we know that the radius of the one of the circle, you can consider radius of one of the circle, vertical line, and we know the distance between this point between B and the center point. So once you know the opposite and adjacent, I can consider sine alpha. Sine alpha can be taken as Ct by Vt or C into delta T, 1 into C into delta T by 1 into V into delta T for the big circle I can consider. Angle will be same. So that C into delta T and V by delta T means the circle or the sphere's radius, what I have considered is C delta T. V delta t is this blue color line, the distance at which the body is moving. Between what distance you have taken, that is Vt. So finally, if you consider after cancelling delta t and numbers, I'll get again C by V. So V by C is Mach number, C by V is 1 over Mach number. So if you consider 1 by Mach number or C by V, one can find out alpha angle. What is the cone angle generated in supersonic or the hypersonic flows? Okay. I hope by this video and the sketches, the points are clear to you. So you need to draw these circles and you have to show the zone of action and the zone of silence for all the three Mach numbers. So lastly, we'll take some numericals on the same equations to find the velocity and other angle of the cone of Mach angles. So first problem is find the velocity of a bullet. So bullet means you can consider a projectile. Find the velocity of a bullet fired in standard air if its Mach angle is 40 degrees. So now Mach angle is given means it is a supersonic or the hypersonic flow. It is having more than 1. That's why it is making a Mach angle or the Mach cone. That half angle is 40 degrees. So Mach angle alpha is given 40 degrees. Now standard air is given, you can take the properties of air. So R as 287 joules per kg Kelvin as like in earlier problem. Gamma you can consider 1.4. Then temperature they have taken 15 degrees centigrade, standard air. So please observe for the standard air what temperature can be considered. Okay. So here they have considered 15 degrees centigrade and they have converted into Kelvin, 288 Kelvin. So at this temperature, the speed of the sound C can be found out by using the standard air properties, that is square root of gamma RT. So they found the speed of sound exactly equal to speed of sound what we take as a constant for different numericals. But here in this chapter, for a given temperature and gamma and R, we have to find out the speed of the sound. So that is 340.2 meter per second. Now to find the velocity of the bullet, that is the velocity of the body, V we have to find out. For that they have given Mach angle and speed of the sound is found out or the speed of disturbance is found out. So using this relation sin alpha equal to C by V, what you have taken here, sin alpha is C by V, or if Mach number is given, you can take 1 by Mach. So same thing is taken here, C by V is speed of the sound 340.2 by velocity of the bullet. So directly you can find out velocity. So velocity of the bullet is coming around 529.26 meter per second. Now by comparing these two, velocity of sound and velocity of bullet, one can tell whether the bullet is moving faster than the speed of disturbance or not. So 529 is more than 340. So it is in supersonic flow. That's why it is forming a Mach angle. Next problem on the similar line. A projectile is traveling. Here also you can assume a bullet or a missile or any object which is thrown by some device. A projectile is traveling in air having pressure and temperature as, so here pressure and temperature both are given, 88.3 kilonewton per meter square and minus 2 degrees centigrade. Temperature is minus here. If the Mach angle is 40 degrees, find the velocity of the projectile. Take gamma equal to 1.4 and R equal to 287. It is on the similar line. You can just follow the above procedure and solve the problem. Only thing here is pressure is given, but it is not at all useful in the problem because no relation or sonic velocity of the sound or disturbance, we cannot relate the pressure. Also in the Mach angle, we cannot relate with the pressure. So pressure is just to given. So here in this problem, velocity of the speed is 330 per meter second and velocity of the projectile is coming around 513.4 meter per second. You can also write in kilometer per hour also. But for objects, we are not writing in kilometer per hour. For a vehicles like aircraft or any four-wheeler or some other objects which are transporting objects, For that, we are writing kilometer per hour. So I think this is the last problem we'll consider with combination of different relations. A supersonic aircraft flies at an altitude of 1.8 kilometers. Okay, and supersonic aircraft is flying from the observer at an altitude of 1.8 kilometer distance. So earlier we have taken 14 kilometer distance. Now it is flying at 1.8 kilometer height where temperature is 4 degrees centigrade. Determine the speed of aircraft if its sound is heard 4 seconds after its passage over the head of an observer. Take R equal to 287 joules per kg Kelvin, gamma equal to 1.4. So when temperature R and gamma is all given, directly find out the C value. So what is C value? C value will give us the speed of the disturbance, not the speed of aircraft. So speed of the sound we can find out square root of gamma RT. That is the last step they have given, 1.4 into 287 R value. Temperature is 4 degrees centigrade, convert it into Kelvin, 277 Kelvin. So speed of the sound here is at this temperature is 333.6 meter per second. Okay, now one part is over. Now next is we need to find out the speed of the aircraft. So for the speed of aircraft, I know the Mach number because by Mach number I can relate the velocity of the body, that is V by C. But here Mach number is not given, simply they are telling supersonic aircraft. We don't know the Mach number. So in place of Mach number, angle is given. Just observe any angle. Angle is also not given. Yes. Other than this angle, they have told two parameters. That is altitude, vertical height. They have told 1.8 kilometers. Okay, and sound is heard to the observer after 4 seconds of this passage. So in the sketch, you can see to find out this angle, what they have done, they have taken vertical distance 1800 meters in meters, that is 1.8 kilometers, and the adjacent line, what they have done, only the speed or the distance traveled by the sound they have given. What they have given, sound is heard 4 seconds after whatever the V delta T I have told. For that delta T, they have taken 4 seconds. So 4 seconds into meter per second, if I multiply, I can find out the distance in meters. That's why the AB distance they have taken 4 into B. Okay, now one can find out the alpha. So when the opposite and the adjacent lines are known, you can apply sum of the angle and can find the Mach angle. This point is clear to all. How they have taken the vertical and adjacent distance. Okay. So in this problem, shall I repeat complete problem? Okay, here a plane is moving. A plane is moving at a vertical height of 1.8 kilometers. The temperature at that condition or the atmospheric temperature is 4 degrees centigrade at 1.8 kilometer height. Determine the speed of the aircraft. So speed of the aircraft we need to find out. If its sound is heard 4 seconds after the passage over the head of an observer. Now assume this O as an observer. O is the observer point. From the observer, the plane is flying at a height of 1.8 kilometers. That is 1800 meters. So A is the point or the line at this height, the plane is flying. After moving above the head of the observer, after 4 seconds, he can hear the sound. So this is going to create some cone here. So half of the cone, if you see, that angle, I can tell it as Mach angle, like this. Okay. Assume that A is the observer. From this point, it is 1.8 kilometer height. The plane is moving from this point to this point. After 4 seconds, he can listen the sound. So this angle, whatever the B side angle is there, half angle, that I can consider it as Mach angle. So same example is analyzed like this. So to find that angle, I can take opposite side as 1800 meters and adjacent side as 4V. Why I have taken 4V? Because I want the distance in meters. That is one thing. One more thing is, in this distance, if you see, in this distance, we can write V into delta T. The blue color line is V into delta T. The circle radiuses are C into delta T. Okay, the magnitude depends. So similarly, what I have done on this line, on the horizontal line or the adjacent line, we have considered V into delta T. Delta T is what? They have given 4 seconds. Velocity unit is in meter per second. If I multiply with 4 seconds, what is the unit of this A to B? It will be in meters. So finally, I want adjacent distance and the vertical distance in meters. And this 1.8 kilometer, whatever they have given, it is not the circle radius here. This is not the circle radius. This is the distance from observer to point. So similarly, observer to point means at point C, if you see at the bottom point, at point C, observer is standing. Exactly at this point, he can listen the disturbance. Once the plane moves from A to B, after 4 seconds, he can hear the sound. So that is analyzed like this. All the points are taken. Now to find the Mach angle, okay, opposite by adjacent, they have taken tan alpha. So tan alpha is opposite side 1800 meters by 4V. Okay, so they found tan alpha is 450 by V. Okay, same thing they can consider in the substitution also. Means V value I can write or alpha I can find out in terms of V, and I can substitute in the Mach number relation. So Mach number relation is what? V by C. So in this place, we are going to find out velocity of the plane. V we have to find out. C is already found out, 333.6 meter per second. C is known to us. So when C is known to us, what I can do now? I can substitute that C value in this formula. Or is also given by 1 by sine alpha. So finally, I can write it as V equal to C by sine alpha. So now to relate both Mach number and this tan alpha, they have taken tan alpha as 450 by V. What is V here? C by sine alpha. So that is substitute in this formula, C by sine alpha. So finally, they can find out sine alpha or the alpha value. So all of you find out the alpha value and tell me. So to cancel that sine value, they have taken again tan alpha as sine by cos. Sine alpha by cos alpha equal to 450 sine alpha by C. So you can cancel sine and sine here. So we left with cos alpha equal to C by 450. So C is what? 333.6. Now if the alpha value, if you are getting some angle, but comparing that velocity, after that we need to velocity, we have to find out. Once you find out the velocity, then I can tell the speed of the aircraft is more than the speed of the sound. Then it is supersonic aircraft. So please all of you find the value of velocity and Mach angle and tell me whether it is supersonic or not. So cos alpha equal to, or alpha equal to cos inverse of 333.6 divided by 450 you can take for finding the alpha value. And for Mach number, you can write V by C once you find out V. So to find V value, you can substitute here C by sine alpha. Yes, you find out and tell me the answers. So take some 2-3 minutes. Find the value of Mach angle alpha and velocity of the plane v. If it is more than c, then it is a supersonic aircraft. Yes, Attar, are you finding the values? Yes, the plane is moving in supersonic because velocity you have found out 476.224 meter per second. Very good. So it is more than 333 speed of disturbance. Mach Mach number is 1.4. Very good. You check the alpha value, Mach angle. So Mach angle is just required to find out the angle because after 4 seconds where it can reach the disturbance. So to find that disturbance propagation, we are finding Mach angle. Alpha is 85.71. One more alpha is 44.471. Okay, which is correct? Yes, we'll see the answers. So velocity is 497 meter per second. So speed they have converted in kilometer per hour, 1189.2 kilometer per hour. So by this cos alpha they have found out 0.7413. You take alpha is cos inverse of this. Cos inverse of 0.7413, you can find out the angle. Or by this also you can find out by sin alpha. It's not necessary. One angle if you find out is enough. Or even by this also you can find out alpha equal to tan inverse of 450 by V. By that also you can find out alpha. Alpha you can find out by tan, sine or cos, whatever. Point 736 in radians, okay. Alpha angle is 42.15 degrees. Okay. Attar, finally you are finding any answers? Okay, angle alpha all are getting 42.15 degrees. Okay. So finally, in the problems, if they have given the temperature, gamma value, anything, you can go by C equal to square root of gamma RT. Or if they have mentioned the bulk modulus and other density or the specific gravity of the fluid, then you can use this formula. k by rho, square root of k by rho. Or in the place of these values, if they have given the change in pressure or change in density, then you can go by this formula, square root of dp by d rho, change in pressure to the change in density. Okay, by anyhow, you can calculate the speed of disturbance, then you can find out the velocity of the body, either by Mach number or some other Mach cone angle relations. Okay. Yeah, this completes the syllabus of fluid mechanics. Now, the work left is the course project and the course seminars. Okay. So that should be completed before 31st of December. And from the IQAC committee, it is very clear that you have to see Akalak Attar notes is already shared in the classroom. I think 1 week back only have shared. You are not aware of that. 1 week back, I think at the time of third, I have shared the fluid mechanics full notes in the classroom. Still, if you have any doubts, you can go through that notes. Okay, you can see that notes. And if any small mistakes are there, please reply me also, Attar. Okay. So coming to the course project and course seminar, before December 31st, you have to submit the PPT and report. Either it may be a course project or course seminar. The earlier doubt was for the course project whether we have to submit the report or the charts. Now it is clear that you have to make a report and PPT for any work. It may be a seminar or a project. In the presentation, apart from normal theory and other things, you can put some pictures of the model, what you have done, or any charts or the process charts you have done in the chart you can put, and those pictures you can put in the PPTs while presenting. Okay. And the presentations can be done in regular classes timings, or else you can, whenever you are free, the group is free with the PPT and the report is ready, then you can present anytime. Just you make a call to me and you can present and you can complete your work. That is for 20 marks, it is evaluated and reduced to 10 marks, course activity work. Once you complete the presentation, after presentation, you have to submit PPT and report, okay, by individual submissions. So I'll be creating course activity in the fluid mechanics class. I think it is already there. I'll show here. Fluid mechanics. Attar, you can see this problem also. If you have any doubts in course activity also, where to submit, what to do, everything, you can see here. Course activity details. December 8, I have created. In this course activity, you have to submit the reports. All the guidelines, okay, guidelines for the course project and course seminar preparation, certificate, what you have to put in the report, course activity cover page. These all things I have added here. Okay. And after this, once you present the PPT and the report is accepted by me, you have to submit in this course activity. So you have to submit PPT as well as report separately by your individual USN logins. By that, you have to submit the course activity details. Say, for example, 60 students are there. All 60 students should submit the PPT and the report in this course activity assignment. Any doubts in course seminar and course project? Okay. Shall I stop the class? Yes, that PDF notes is enough for SEE, provided if any mistakes, okay, or any problems. Coming to the numericals and problems, you have to solve or practice any number of numericals from any books. That is not restricted. But coming to the PDF file, the theory part, the sketches and the types of problems are enough from that PDF file. A small, any mistakes are there, you have to overcome, or you can just reply to me. All of you understood? And regarding the problems, you can refer one book, that is R.K. Bansal, or what book I have shared with you, that is Rajput. Either Rajput or the Bansal, both may be having some mistakes in the numericals that you have to overcome. That's why I'm telling from the first class, use the calculator and check the answers and reply me. So as you've done today, some numericals you have solved by calculator and told me the answers. Similarly, you have to use the calculator and check the correctness of the book also. Any other points? Shall I stop the class?